Hello students, today we are going to see reaction of metalloenamines. We have already seen Stork-enamine reaction in which we know that the aldehyde or ketone gets converted into an alkylated ketone. But the problem with Stork-enamine reaction is that in presence of excess alkylating agent, anion will again get alkylated at alpha position, which will result in formation of polyalkylated product. To solve this problem, availability of alkylating agent can be restricted, but still it gives mixture of product when alkylated product is wanted. So for that, the solution is metalloenamine. So metalloenamines are highly nucleophilic enamine anions, which are often N-lithio or N-magnetio derivatives. They are also called aza-enolates, and they are formed by deprotonating an imine with strong base like Grignard. So here is the first example. Here we have carbonyl compound which reacts with amine. First H2O will be removed and we will get imine or skiff base. Now hydrogen of this alpha carbon will be removed. So electrons of this bond will transfer here and create a double bond. And electrons of this double bond will shift to the nitrogen and create a negative charge on nitrogen. Now this enamine will react with Grignard. Here Grignard reagent will act as a strong base and MgBr will get attached to this nitrogen. Further it will react with benzyl bromide, which is less reactive alkyl halide. But chelating effect of this magnesium ion and the negative charge which will be formed here on this nitrogen, it will shift the site of nucleophilicity to this carbon. So here the alkyl group will get attached. So now further with hydrolysis, we will get an alkylated ketone as a product. Now let's see another example. Here again we have ketone and we have amine. First H2O will be removed and we will get imine. Now again Grignard will react with this imine. Grignard will act as a strong base. Ethyl has partially negative charge, MgBr has partially positive charge. Here due to deprotonation on the alpha carbon, nitrogen is having a negative charge. So this MgBr will get attached to this nitrogen. So this will be forming a metalloenamine. Now this MgBr will be removed. Electrons of this bond will transfer here and create a double bond. Electrons of this double bond will be shifting here and creating an carb anion. Now it will react with butyl bromide. So bromine has negative charge and this alkyl group has partially positive charge. So this butyl group will attach to this negatively charged carbon and we will get this. So after the hydrolysis we will get alkylated ketone. Our initial substance was ketone and here alkyl group is connected. So we get alkylated ketone as a product. Now let's see last and very important example. Here we have alpha beta unsaturated ketone which reacts with cyclohexylamine. In first step H2O will be removed and we will get imine. Now here we have alpha beta and gamma carbons, but proton will not get extracted from alpha carbon. It will get extracted from gamma carbon, because if we extract proton from alpha carbon it will create unconjugated enamine system, while if we extract proton from gamma carbon it will create conjugated system. So let's see how it creates conjugated system. This proton will be removed and electrons of this proton will be transferred here and create a double bond. Now this double bond will be shifting here and it will create a double bond here, and electrons of this double bond will shift on the nitrogen and create negative group, negative ion. So we can see that this system is conjugated. Here we have double bond and negative charge. We have used LDA here, so here Li plus will also be there. So here we have got our metalloenamine. Now this negative charge will shift here and create a double bond. Now electrons of this double bond will be shifted here and it will create carbon ion. Again this reacts with iodomethane. Iodine has partially negative charge and methyl has partially positive charge. So it will get attached here and here is what we get. Now hydrolysis will take place and we will get beta gamma unsaturated alkylated ketone. Now the problem is that here ketone and double bond, they are very far away, so it is not stable, so it will further undergo tautomerism. So we know that proton from this alpha carbon will be removed and electrons of this bond will be shifting here and create a double bond. Electrons of this double bond will be shifting here on oxygen and it will create negative charge on oxygen. Now this negative charge will revert back. Electrons of this double bond will be shifting here and create a double bond, and electron of this double bond will be shifting here and create carbon ion over here. Now the H plus which was removed, it will get attached here again and it will give alpha beta unsaturated alkylated ketone as a product. So this will be our final product and it is stable than the beta gamma unsaturated ketone. So the advantage of metalloenamine reaction is that it enables the reaction with less reactive alkyl halides by the action of Grignard base, and the another advantage is that it prevents polyalkylation of ketones. Thank you.